Hi everyone, this is Dr. Swaminathan Yasyam, Associate Professor EC Department, SNS College of Technology. Now I am going to discuss about the topic called root locus techniques and construction under the unit of stability analysis. So review about the previous class. Last class we discussed about the root Hurwitz's criterion. So here introduction about the root locus techniques and the rules to construct the root locus following to the activity rules under the root locus and the following summary. So first thing, root locus is the locus of the roots of the characteristic equation by varying the loop gain or system gain from 0 to infinite. So 1 plus g of s h of s equal to 0. Then the point on the root locus, that is branches, satisfy the condition to know whether the point exists on root locus branch or not. We can find the values of k, that is the loop gain, from the location of the points, that is root locus branches, by using the magnitude condition. And next, introduction about the characteristic equation for the closed loop system. Then you can get g of s h of s is equal to -1 plus or plus j 0. Then you can get the phase angle tan inverse of b by a. So in the side, a plus jb means that is b is nothing but 0 and a is nothing but 1. So you can get 2n plus 1 into pi. The angle condition is the point at which the angle of the open loop transfer function is an odd multiple. That's why it is called as 2n plus 1 into pi. Next to the magnitude, that is modulus of g of s and h of s equal to 1. The magnitude condition, that is that point which is satisfied the angle condition at which the magnitude of the open loop transfer function is 1. So the rules for the construction of the root locus: first one, locate the open loop poles and zeros in the S plane. And second rule, find the number of root locus branches. So based on the branches, you can say mathematically n is equal to p if p greater than or equal to z, n is equal to z if p less than z. And the rules for the construction, again the three, identify and draw the real axis root locus branches. So if the angle of the open loop transfer function at a point is an odd multiple, that is 2n plus 1 into pi, then the point is called the root locus. If odd number of the open loop poles and zeros exist to the left hand side of the pole on the real axis, then that the point is on the root locus branch. Therefore, the branch of points which satisfies the condition in the real axis of the root locus branch. So following to the group activity group discussion, you can see. So root locus and the branch, that is in the left hand side, -5 and -1 to 0, and it's not in the root locus branch between the -1 to -5. And again you can get the rules 4, find the centroid. So centroid, the formula sum of folds minus sum of zeros divided by n minus m, and the angle of asymptotes, that is nothing but 2q plus or minus 1 into 180 degree divided by n minus m. M is nothing but number of poles and m is nothing but number of zeros. So based on the p z conditions, it varies. And again, this is the rules for the construction. That is first thing, that asymptotes with 60 degree and again 180 degree, and the centroid you can find using the formula, that is equal to -2, and asymptotes is 300 degree angle. And again find the breakaway point. So breakaway point you can find, that is based on this exist on the root locus branch between the two open loop poles. Between the two open loop poles you can find, and this two open loop zeros you can find. So 1 plus g of s h of s equal to 0. Then differentiate the term and substitute the s value with this equation. Then you can get the s value equal to k. Then you can find the breakaway points. And next, the sixth point is called find the angle of departure and angle of arrival. So the angle of departure and arrival, that is calculated based on the complex conjugate of the open loop poles and the complex conjugate of the open loop zeros. That is rule 6. And rule 7, that is intersection point on imaginary axis. That is, you can find imaginary axis means then you can get s is equal to j omega. Then you equate the real part and imaginary part separately. Then you equal to the 0. Then you can find the values. So based on this, you can find the breakaway point for 0.473. Then you can make this breakaway point. And these are all the important thing you need to consider for the root locus methods, that is your root locus rules. Thank you.